Thank you for waiting. So now technology session 2, actions needed for realizing carbon neutrality in heat and transport sectors with hydrogen and e-fuel e-methane shall commence. First of all, I would like to introduce two moderators for the session. Professor Dr. Georg Erdmann and Mr. Vikram Mehta. Professor Dr. Erdmann is an ICEF Steering Committee member, retired professor for energy system at Berlin University of Technology, and president of the board at KSB Energy AG Berlin. And Mr. Mehta is also an ICEF Steering Committee member and chairman of the Center of the Social and Economic Progress Research Foundation. And now, I would like to ask Professor Dr. Erdmann to moderate the session. So Professor Dr. Erdmann, if you please.
Thank you very much, and good afternoon to this, I think, important session. I welcome particularly my co-moderator, Vikram Singh Mehta from India. He is an independent from an independent policy think tank, and I will give him the chance to give also some remarks after my introduction. And of course, he can always intervene in the discussion as he wants. So what is the problem? We are facing a very curious year. This year was very unexpected. Very high temperature. Everyone is now aware that we have a problem with climate change. Second, energy crisis, shortage of gas supply and also electricity supply in some regions in the world. It's not only due to the war in Ukraine, but also to the climate change, because if the rivers have no water, you can have difficulties to produce electricity. And last but not least, we have very high gas and electricity prices, in particular in Europe. So if you add these three challenges together, you must say there's an optimal chance for innovations. Awareness, high prices of conventional fuels, plus security of supply issues. This should be really a driving force for innovations in the segment of heat and transport. So we should not welcome this crisis, but we should use them as a trigger for more innovations. However, what we can observe today is that governments use a large amount of money to stop or to dampen the price impacts of the present developments. In particular, the German government last week announced to spend up to 200 billion euros, that is twice the GDP of the Ukraine, in order to subsidize energy prices. Maybe they will also spend some money for innovations, but most of this money will be spent for subsidizing industry, households, and small businesses. This in mind shows that the road to net zero may become longer and more difficult than we anticipated in our modelings. We did not expect that the governments are doing the contrary of that, what should be done in order to go the direction of net zero. Anyhow, never waste a good crisis. It is a chance for innovations in the heat and transportation sector. This we will discuss this afternoon. The topic are the latest challenges and trends of hydrogen and synthetic fuels in this area. So I welcome 4 speakers. The first speaker is Yabe San. He is fellow from the Sustainable Energy Unit Technology Strategy Center, New Energy and Industrial Technology Development Organization, the NEDO, our sponsor, one of our 2 sponsors. The second one is Yakabe San. He is Executive Officer, General Manager of Hydrogen and Carbon Management Technology Strategy Department at Tokyo Gas. So welcome, you too. Then we have 2 speakers from Germany, which are connected with us over video. One of them is Monika Griefahn. She is chairwoman of the board of the E-Fuel Alliance. This is an interest group committed to promoting e-fuels and to securing their regulatory approach. And then we have Ruben Furi. He is business developer at Enapter, and Enapter is developing anion exchange membran. I hope that Ruben will explain us what this is. And this company develops hardware as well as strategy to reduce costs via standardization and mass market applications of this new technology. So we have a broad discussion. I will stop here my introduction. Maybe Vikram, you want to add something?
Well, I just want to add my welcome to all the participants and in particular to the speakers, members of the panel. As you said, George, we are facing a crisis from multiple angles, and technology is and has to be the basis on which we address it. We have to address it in a manner that not only promotes the welfare of society, but at the same time recognizes and appreciates the importance of social justice and equality. And this will only be possible if technology and innovation is managed through a collaborative effort by all concerned. So I just wanted to say this session is very important, and I'm really honored to be part of it. And once more, welcome to everyone, and I look forward to the discussion.
Thank you. Now I will ask Yabe-san to start its presentation.
Thank you for your introduction. I want to use video. Please, video, please.
My name is Akira Yabe, Technology Strategy Center of NEDO. The title of my presentation is Systematic Classification of Heat Demand for Industrial Processes and the Systematic Overview of Mobility and their Future Decarbonization. At first, I will explain the importance of industrial process heat and mobility. Industry uses 1/3 of total energy consumption worldwide. Heat demand of industry process is 3/4 of industrial usage. This amount is very large and equivalent to about half of the total generated electricity. As for transport, the transport uses 1/3 of total energy consumption. This amount is also very large and equivalent to about half of the total generated electricity. Therefore, if we replace this usage by electricity, the total amount of electricity generation should be increased to be doubled. I will discuss the decarbonization of the industrial process at first, and then future mobility overview. As for the heat demand of industrial process, the 3/4 of the total heat demand has been due to industrial furnace. In the left-hand side, the horizontal line is the temperature. For the iron and metal industry, shown as green color, wide range of temperature is needed. As for chemical process, shown as gray color, also needs wide range of temperature. In the right-hand side, the pink color area is the usage of industrial furnace, which is composed of combustion furnace and electric heating. Blue colored area is the steam and hot water supply, which is composed of boiler. We made systematic categorization of industrial furnaces according to the temperature and output power. As for the combustion furnaces, shown by pink color, its output range widely with temperature below 1,600 degrees. As for the electric furnaces, shown by blue color, there are two regions. One is relatively low output range below 2 megawatt, and the second region is high temperature area above 1,500 degrees. There are two future directions. Since the fossil fuels are used for combustion furnaces so far, as for combustion furnaces, the fossil fuels will be replaced by hydrogen, ammonia, and biofuels. Second direction is the enlargement of application field for electric heating to the area of combustion furnaces to realize the carbon neutrality. As also steam and hot water supply, which is supplied by fossil fuel combustion boilers so far, as for the steam supply, the hydrogen fuel cell, high temperature heat pump, and the hydrogen boiler are the important candidates. As for the hot water supply, electricity-driven heat pump system is a main candidate. As for the mobility, we made a systematic classification for the application field of various kinds of mobilities from the viewpoint of output of engine or motor and the total amount of stored energy. In this figure, pink area is a gasoline engine and the green area is a diesel engine. This plot includes not only internal combustion engine, electric vehicle, fuel cell vehicle, but also helicopter, drone, ship, agricultural machines, power shovel, and forklift, nearly all kinds of mobility. Yellow is EV, and blue area is fuel cell vehicles. From this figure, future direction towards 2050, EV will cover the field of gasoline engine, FCV will cover till larger stored energy field. The large diesel engine field will be replaced by biomass liquid fuel and synthetic fuel, as well as EV and FCV. This is the conclusions. The heat demand for industrial process is systematically classified, and as for the main usage of industrial furnaces, the combustion furnaces using fossil fuels should be replaced by the combustion furnace utilizing hydrogen, ammonia, biofuel, or by electric heating. As for the mobility, the systematic classification shows as a future direction towards 2050, EV will cover the field of gasoline engine, FCV will cover the larger stored energy field. Large diesel engine field using fossil fuels will be replaced by biomass liquid fuel and synthetic fuels, as well as EV and FCV. Thank you very much for your attention.
Thank you very much, Yabe-san. I think this speech was very clear, so we can go to the second speaker, which is Yakabe-san from Tokyo Gas.
Thank you, Mr. Chairman. I'm Sataka Yakabe from Tokyo Gas. It is my great pleasure and honor to participate in this wonderful and excellent international symposium and have an opportunity to give my talk, as well as Mr. Yabe. Before this session, I have already submitted my video. Therefore, instead of my live talk today, I will use my video. And could you please start my video? Hello, everyone. I'm Hisataka Yakabe from Tokyo Gas. It's my great pleasure to give my talk at this ICEF meeting. Today, I will talk about initiative of Tokyo Gas toward carbon neutrality, implementation of e-methane. This slide shows Tokyo Gas business and how we will decarbonize our company's business. Tokyo Gas is an energy provider, and our business is based on natural gas value chains. In our company's strategy vision toward 2030, we are committed to carbon neutrality in 2050. To realize the carbon neutrality, these three perspectives and measures are the important points: green transformation, resilience of energy, and effective use of existing infrastructure. From these perspectives, we consider e-methane is the most effective options of energy carriers. E-methane, that is synthetic methane, is produced by reacting hydrogen with CO2 recovered from factories or thermal power plants. The utilization of e-methane doesn't increase CO2 in air overall. The most advantage and benefits of e-methane is that existing infrastructure can be used without any further modification and additional cost. The middle diagram illustrates a domestic CO2 recycling model, and CO2 in air won't increase in this model. The bottom here shows a supply chain model from overseas. Using inexpensive renewable energy, green hydrogen and then e-methane is produced. After the LNG shipping terminal, all existing facilities and infrastructures are available as is. This is a roadmap for social implementation of e-methane. We consider 3 steps for the implementation. Step 1 and 2 are domestic small-scale and middle-scale demonstrations, and the step 3 is the large-scale overseas supply chain establishment. We have already studied the small-scale demonstration, and by 2030, we will introduce e-methane equivalent to 1% of the city gas volume, and the plant scale is around 20,000 cubic meter per hour. This slide shows the detail of small and middle-scale demonstrations. For small-scale demonstration, we have already studied the evaluation test on the methanation plant at our laboratory in Yokohama City. The left figures display the demonstration field and the plant. The system scale of the methanation plant is 12.5 cubic meter per hour. We will collaborate with Yokohama City, and recycled water, biogas, and CO2 will be provided as raw materials. The right diagram shows a scheme of middle-scale demonstrations. These are regional cooperation model and on-site utilization model. System scale is several hundred cubic meter per hour, and a characteristic feature of the regional cooperation model is that the produced methane will be injected into city gas pipelines. The middle-scale demonstration is an important step not only for scaling up the system size, but also for deployment of e-methane in Japan. To achieve the goal, it is very important to meet society's needs for cost. We consider even in 2030, the cost will be still high relative to the cost of natural gas. The left figure shows the cost structure of e-methane. Green power accounts for the largest proportion of the cost, and it is important how to procure inexpensive power and to produce methane in a highly efficient manner. To achieve the goal, innovative R&D, partnership, and institutional design and public support are significant factors. To improve the efficiency and reduce the cost of the plant, further technological development is necessary. To build a supply chain of e-methane, strong alliances with many partners and stakeholders are important. We also expect institutional and financial support by the government. The last slide shows the global decarbonization activity. We are currently working with trading companies and global energy companies on feasibility studies for supply chains of energy carriers in North America, Malaysia, Australia, and other regions. We consider that the US is the most promising candidate for an e-methane site, and we are now focusing on the US. We are also working collaboratively with Shell on hydrogen, biogas, e-methane, ammonia, and CCS. This is a summary. In order to carry through responsible transition toward a carbon-neutral society, Tokyo Gas is going to promote the decarbonization of both gas and electricity, while selecting appropriate carriers considering the time frame and technology maturity. We will specially focus on the introduction of e-methane. In the future, we will contribute to local and global carbon neutralization as a decarbonizing energy player in the thermal demand sector and create new decarbonization model originating from Japan. Thank you for your attention.
Thank you very much. I have a question. When you start such an innovation project, probably you have ideas how you can reduce the cost for e-methane. Do you have strategies for that?
So the important point is innovation. And so now we are trying to develop new technologies. And in addition to the conventional technology, so we will employ new technology. And thanks to Japanese government support, especially by NATO, so we have already started Green Innovation Fund and technological development in Yokohama area. Mm-hmm. And the fund value is $30 million. And it is a very big fund. So we will develop for 10 years. Mm-hmm. And in 2030, we will realize the new technology.
Is Tokyo Gas suffering the price hikes we have actually in Europe?
Yeah, so we want to, so in the future. And
does Tokyo Gas experience the same high gas prices as we have actually in Europe? It's about 200 to 300 euros per megawatt hour gas. This is extremely high. Do you have similar prices? Because that means there's a chance for...
So we, Japan, face the same situation. And
okay.
Yeah, in the future, so we hope that maybe the natural gas price will decrease. However, we should meet the society needs about the cost. Okay. That's very important.
Thank you very much. We will continue the discussion on this point, I think. So let us come to our third speaker, Monika Griffan from E-Fuel Alliance. Monika.
I have also prepared a video, so there you have some slides with it. Please start the video. Hello, welcome. And I'm very happy that I can participate in this conference, also from abroad. I'm Monika Griffan from Germany. I'm the chair of the E-Fuel Alliance, and the E-Fuel Alliance is an association of about 180 members along the supply chain from 16 countries. We have members which are either companies who produce machinery, who sell oil, but also consumer organization like the ADAC, which is the biggest consumer organization in Europe with 21 million members. And we are very happy that we work together to make the world a little bit more sustainable. We need everything to solve the climate change problem. And that's why we work for e-fuels. What is it? E-fuels are made out of basically water and renewable energy. And you have an electrolysis process, and you make then out of hydrogen out of it. And together with the CO2 out of the atmosphere, you produce then a liquid or a gas, which can then be transported like fossil fuel. And it is in normal refineries, you can produce kerosene out of it, diesel out of it, fuel out of it, and it can be used in any machinery like a fossil fuel. And that's why it is so important to use it additionally to the electrification, which we have in all places, because we don't have enough renewable energy in most places of the world, but we have some places in the world which have much more renewable energy than we have in our countries, for instance, in Europe. So if you look what we can use it for, you see you have along the different transport sector, you have cars, you have fuels, you have ships, you have planes, you have trucks, and everything has to be more climate neutral. And with e-fuels, it can be more climate neutral because it's only water and CO2. And in the combustion system, it then produces only CO2, which we have used before out of the atmosphere. And if you see what sometimes is said, is more expensive to use renewable energy to produce hydrogen and then e-fuel out of it, it is a system which can scale up after a while, and then it will be as cheap as fossil fuels today. And that's why we propose that you add e-fuels in the first time to the normal fuels and you make a blending. And if you do that, then the price is affordable and you can scale up over the time into a system where you have a lot of e-fuels and can even use 100% of e-fuels in those systems where you cannot electrify by electric cars or electric machinery or batteries in a system. So we have a lot of places in the world where you have a lot of energy. You see that here, where you have a lot of wind or you have a lot of sun, and you can produce a lot there. And there are areas where you have good possibilities to do that. For instance, these are some projects which are existing at the moment. For instance, Chile, which has is a production system out of Porsche, of Exxon, of Siemens, and they produce from September 22 onwards about 550 million liters of diesel, and they will use it first in their Porsche cars, of course, because 75% of all Porsches are still running. And what we need is basically a political system which agrees that e-fuels are a solution beside electrification. So the European Green Deal, for instance, is mentioning that we can really have a lot of directives where we can include e-fuels, not only battery systems, not only direct electric systems. And we are working on that with the Renewable Energy Directive to have the same tax situation in the European Union than for electric battery systems. And we have very good points why e-fuels are so necessary to use, because it takes a long time. If you look at the world, we have 1.4 billion cars, we have 90,000 ships, we have 27,000 planes, which are already existing. So when you don't want to scrap everything, which you can't do because you need also the natural resources for that, it's necessary that we have e-fuels to use it in all the existing devices. And you see, you can also keep a lot of working places, you keep the engineering knowledge, and that's very important. And that's why I think it's an important point, and I'm very happy that on this conference you discuss about e-fuels as well. Thank you very much.
Thank you, Monica. I have two questions. One is on slide 6. You have shown the price for gasoline, 2 euros per liter. Maybe you can show this slide? No. And 2 euros per liter, actually, this is a discount price. I think it is closer to 3 euros per liter than to 2 euros, the present price, gasoline price in Europe. So that means maybe the entry point for these e-fuels is really a good chance. Maybe you can comment on that. And then, of course...
Yes, you're right, because this slide was made when half a year ago or so, when fuel was the price in that way. So we have probably to adapt the slide this. Now.
Okay,
right.
but definitively 70 cents per liter is much money. If you can produce e-fuels for this price, then or at least blend conventional gasoline with some e-fuels, that is very good. And the second question is, e-fuel an option to avoid CO2 taxes from the point of view of European Union, where you are standing here?
Yeah, the point is we are discussing the European Energy Directive, and at least they have agreed that between 2.7 and 5.6% is possible to blend, but the tax situation is still unclear in some countries. For instance, in Germany, e-fuels is treated as if it would be a fossil fuel. That we have to change, and I hope that other countries give also an input to change that, because it's unfair if you have a fossil fuel where you want to have the CO2 taxed, but at the same time you free battery systems and electric systems from tax, although the electric production at the moment is also partly done by coal or oil or gas from fossil sources. So it's unfair, and you should do that because synthetic fuel basically is only out of water and only out of CO2 out of the atmosphere. It's much better than the actual mix of electricity.
So this is an example.
May I ask one question?
Please.
George, Monica, you mentioned that politics or the political support is a key factor for success. Is that the major challenge you face, or do you feel that the standardization of norms across different parts of the European community is going to be a comparably severe challenge to overcome?
I think the cooperation between the companies are already very big. But the political system at the moment is a little bit difficult because everybody looks onto electrification of everything. So you want to have battery cars, you want to have heat pumps for heating in houses, etc. But what we say is you cannot have all the production of the energy yourself in your country in the place. You cannot have 100% renewable energy use in Germany for everything you need. So as we have, for instance, in Germany at the moment, 80% of import of fossil fuels, I think it is very logical that you still import fuels, but you import them from renewable sources. And that has to be accepted by the political system, and you need some framework which bring the incentive for the companies to really invest. And at the moment they want to invest, but they don't know whether they can be successful in selling it, because in Germany, for instance, it's even not allowed at the moment to blend it, you know? So we have to make steps forward, and I don't know how it is in other countries. We are working internationally in 16 countries now, also in Japan, and we hope that we can really harmonize these systems.
Maybe Yabe, you can comment on that? Yabe-san?
Yes. And about this one, as I explained in my presentation, there are several candidates, and this e-fuel is one important candidate, but we should take how much amount and how is the cost and how is the effect to carbon neutrality. We should care about that. Then we select which is one. And also, everyone has a very severe target of research. Therefore, we should also focus on the level. Okay. And Japan also support this one. Okay.
So, but there are not yet tax exemptions from fuel taxes for e-fuels.
Yes.
Yeah. Maybe Jakabe-san, you have, because you showed e-fuels also on one of your slides.
Yeah, that's right. Before the presentation of the last person, so I will ask both the chairman and Ms. Monica about the same issue. So in a broad sense, e-methane is one type of e-fuel.
Yes.
Mm-hmm. And all have the same issue for the implementation. Mm-hmm. And one is how to procure CO2 and the institutional design of e-fuel for cross-border trading. And so I'm very afraid that in the future, e-methane isn't recognized as a carbon neutral fuel or gas. So because of the CO2 issue. And so usually if CO2 is derived from direct air capture or biomass gas, it is all right. On the other hand, if CO2 is derived from fossil fuel-based exhaust gas, that's a problem. And in the EU taxonomy, maybe so the reduction of CO2 or greenhouse gas should be over 70%. And maybe if we use only exhaust gas, maybe the reduction of CO2 is about 50% if we don't recycle CO2. Therefore, maybe the additional tax will be imposed to the production of our customers. Therefore, so we hope that to prepare such kind of institutional design in the future.
I have problems to see whether some of you in the auditorium want to give a comment or speak. maybe I'm too much. You are here black in front of me. There are too much light. So if you want to, please come and in front, and then you ask your question. But what is my conclusion about this discussion is that maybe politics is hindering innovation and not promoting. Normally, the politics should at least promote by not taxing, by not putting a CO2 price on a green fuel, etc. Or if it is 2% or 5% or 10% green, then you have to reduce the CO2 tax on it accordingly. That should not be a big deal. But obviously, what is the reason that it is so difficult?
Yes, but we should think about the 2050, that is carbon neutral, neutrality. Therefore, 10% or 20% is, we should care how to remove these ones. That is my point.
So your statement is...
CO2 for e-fuels is basically out of the atmosphere, and it's only that what you took out goes back. So it's not additional. And at the moment we have, we discuss about, we have additional CO2 all the time through the fossil fuels, right? And the e-fuels basically take out the CO2 out of the atmosphere and then only produce that back if you're in the combustion system.
Okay. So the problem is...
So it's neutral. It's neutral.
Today we have not yet an approach to tax this kind of, or use a CO2 pricing mechanism for this kind of new technology approaches.
Yeah.
Okay.
That's an important point. It's a basic incentive for investments as well.
Yes, that's what we have heard very often in the past.
If I might ask something to Ms. Griffan, I would like to ask if it's what is the most critical technology which is not ready yet? Is it carbon capture from the atmosphere? Is it hydrogen production? Is it renewable energy, or all of them?
Now, renewable you can produce very cheaply in those areas where I showed you that you have a lot of wind, a lot of sun, and you can do it very cheaply and very easily. That's why also this production site, the plant in Chile, can produce very cheaply in the future if you raise it into big scale. But I think the carbon capture out of the atmosphere is a critical path at the moment, and we need that, of course, develop much more as we have at the moment, because we need it anyway. You know, we had in 1900, we had 280 ppm CO2 in the atmosphere. Today, we have 420 ppm in the atmosphere. So we have to get it out anyway. This needs a technology anyway.
Thank you.
Okay. I don't...
But Ruben also has presentation still, huh?
No, from my point of view, I see the problem here that if you talk about 2030 or 2050 with very ambitious targets, then you hinder the progress in the next 5 years to 2025 or 2027, because the first step is the most important. Even if it will not end up in a net zero world, simply because we are not yet there. But at least we should start this approach, and we should demonstrate this technology strategy could end up in a clean world.
We have a lot of companies who are really ready to invest, to work, and they have made the technology. And I think the technology is ready. We only have to do it, and we have to give the incentive and the permits. I mean, at the moment, a gasoline station in Germany got a fine because they sold this fuel to a tractor company, you know? So I think it's stupid. We have to change legislation as well.
You don't think that finance is an obstacle, Monica? And in particular, finance or investment in infrastructure to ensure that we receive an uninterrupted supply of renewables.
But you know, the positive thing about e-fuels is that you can transport them with the traditional methods. You can transport them with tankers, you can transport them with pipelines, you can distribute them through normal gasoline stations, you can have them in the seating systems. So I think the infrastructure is there. You only have to build up now the electrolyzers and the plants to put the CO2 out of the atmosphere into that, and then you can produce it. And in those countries which have a lot of renewable energy, it is also a good business for them, a good business case for them. And we have then also a business on eyesight, you know, on the same level, and that's also very attractive, I think, for also those countries who produce it. So I hope that we really overcome these legislation problems, because the investments, I hear everywhere people are ready to invest into that because they see the future as it is CO2 neutral.
Did you observe the slide of Ruben, who showed us that the share of e-fuels in the gasoline mix should be growing from year to year? And is this a strategy which could help to develop the market, or develop and to go into the direction of the transformation of energy systems? Of course, you need the government which promises not to tax CO2 and fuel which has not CO2 impact. But of course, this must be negotiated maybe by your organization. But I think the strategy to go step by step, as Ruben proposed, what do you think about that?
But Ruben hasn't showed yet his presentation. Can you ask him to do that?
I will show it ASAP.
Oh, sorry. Okay. So, Ruben, it's your turn.
Yes, so I did prepare a presentation. I did not record it, so I will give you guys a live presentation. So maybe we can just go ahead and start if you want to share the PowerPoint. So perfect. So we've talked a lot about decarbonizing the energy system worldwide, and this, by the other speakers, has been tackled with e-methane and e-fuels. So basically bringing renewable energy to a form of molecules, so fuels or gas, which can be easily handled and easily used in existing infrastructure. So this was the point from Ms. Griffin and the guest from Tokyo Gas. And basically what it's missing now, at least from our side, is cheap green hydrogen generation. So that's what Enapter is coming up to do, and I will show you now a bit what's our plan and why we do what we do. But in short, we are focused on reducing the cost of green hydrogen generation through our pioneering technology, AEM electrolyzers. So next slide, please. In short, Enapter is a very young, innovative company founded in 2017, but our technology has been researched for 10 years prior to that. And now our main goal is to bring it to mass manufacturing, and we're doing that. We're building a big production plant in North Germany. You can see the picture in the bottom right corner. So far, we are about 250 people, headquartered in Italy and Germany. We're a stock-listed company in Frankfurt and Hamburg Stock Exchange, and yeah, our main goal is to bring hydrogen to a standardization approach, to a modularity approach, and the goal is to ultimately reduce the cost. Next slide, please. But why do we need hydrogen in the first place? I mean, this graph really shows it clearly. We are using a lot of energy, but most of that energy is coming from molecules, so gas, fossil fuels, etc. Only 20% is being consumed under the form of electricity. So it is true that we are electrifying a lot of processes, including mobility and heating, etc. However, it has been mentioned already that it will not be possible to completely electrify our energy needs. So what is needed is a way to capture those cheap renewable energies and to make them into a molecule form, which can then be used to decarbonize all sorts of sectors, from industry to mobility to heating. So next slide, please. Also, this graph shows you how the energy power generation will shift in the next years. So I mean, maybe you're not able to see the colors so well, but in summary, we will see a dramatic shift to solar and wind generation, meaning that the production capacity per plant, for example, will shrink from the gigawatt size to the multi-megawatt size. So we need a way to intercept those renewables, which will inevitably come to our energy grids. So we will have an excess of power, which we actually need to make something with. So next slide, please. What Enapter is proposing is to have a massive scale of electrolysis, which can intercept those renewable energies which will come online in the next years. So through renewable energy and water, and through our AEM technology, we want to enable green hydrogen at cheap costs for other companies like synthetic fuels, e-methane and mobility, for those sectors that really need a building block to decarbonize their solutions. So we provide the building block of green hydrogen. And yeah, in the next slide, I will show you how our very big goal of producing 10% of the total hydrogen produced by 2050. And basically, that's a very ambitious goal, and we are confident we can achieve that by two simple reasons. One is so those are the differentiating factors that really put Enapter aside. The first one is our technology, of course, and we can see in the next slide, our technology is what our core company and know-how is going around. So we have developed and we have commercialized. We're the first one in the market to commercialize the AEM technology, which is basically best of all of the current electrolyzer technologies in the market. We can have high performance with low cost of materials. So we are not using any of those expensive materials which you can see in other technologies and will create a bottleneck in the future. So we use low cost materials like stainless steel, like nickel, for our core technology. And this is one of the enabling factors which will allow us to have cheap hydrogen. But the second factor, we will see in the next slide, is our platform approach. So basically, we want to achieve what has been done with the solar panel and the computer industry and also the battery industry. So achieving a commodification of a standardized product. We want to go away from a big industrial customized plant to a unit to an electrolyzer unit which can be standardized and mass produced in very large volumes. And this strategy, combined with the low cost and high performance of our technology, will enable us to achieve such green hydrogen cost, which all of the industries right now are needing. And next slide, please. So as you can see from this graph, this is our current strategy. We are pivoting all of our electrolyzers around one standardized modular AEM stack module. We can manufacture this very high quantity, very high volumes, and very low costs. And then we basically implement this in a battery system fashion, like you would see in an electric vehicle. Many of these stack modules in series, in bigger and bigger systems to achieve any power of electrolysis required for e-fuels production, to e-methane, to hydrogen directly for industry that need hydrogen directly, etc. And in the next slide, you will see our manufacturing plant, which will produce all of those standardized modules in an automatic fashion. So we are also the pioneer of bringing this technology to mass production. We will have a fully automated factory producing many thousands of those stack modules per month. So we are really looking forward to bringing this factory online beginning of next year. In the next slide, we will have a look at a few of our examples and project examples and what can really be done and what has been done with our technology. Next slide, please. This is a white labeling example of a very innovative company in Australia building up a home power system with our electrolyzer, some hydrogen storage, batteries, and basically it's packed up into a compact system for residential use. But this is only one use, of course. In the next slide, we will see some heating solutions for district heating in the Netherlands. So they have used 8 of our modules, put it next to district heating in the Netherlands, and this is used for heating homes directly with hydrogen and hydrogen boilers. And the next slides, we will go more into refueling applications, so for mobility. So you can see how versatile hydrogen really can get, and all of those use cases have already used our commercially available technology. And the next slide will show the more industrial use cases. This is a pilot plant for ammonia production, and this is of course green ammonia. Basically uses 30 of our modules, and you can see how many modules together can create bigger and bigger systems. This is of course only the project we've had so far. Our plan is to scale significantly to much larger sizes. Finally, in the last slide, there is a more fitting example. This is actually green methane synthesis. So our electrolyzers are producing hydrogen that then goes and creates biomethane. This is together with a German company. So basically we want to enable, just next slide please, it's also the last one. We want to enable smart, simple and scalable, affordable green hydrogen for decarbonization of all of the industries that cannot electrify through e-fuels, through e-methane, through direct hydrogen use. So that's our goal, and we are moving fast to achieve our goals in the future.
Thank you very much, Ruben. Here's a question from the auditorium. Which is the main type of electrolyzer to produce e-fuels?
Is the question for me?
Yeah. Oh,
so I'm actually, this maybe would be a better question for Ms. Griffin, but I feel like at the moment e-fuels are still in the initial phase. So I'm not aware of any large-scale e-fuel production, but if I would have to guess, would be the more established alkaline systems which are used for e-fuel production. But this is just a guess. Maybe Ms. Griffin can comment here.
Monica.
Actually, I think you're right that, for instance, in this first bigger scale company in Chile, they use a traditional electrolyzer, of course. And I think you're right. We have to have innovations in all sorts of technology, also in that, so that everything gets more efficient and more cheap. But I think the bottleneck at the moment is really the CO2 capture out of the atmosphere. And I probably want to urge companies to research more on that.
Yes, I agree. That's why I asked you before.
Okay. I have another question. It's for me. What are you did some innovations, obviously successful. So, of course, if you do innovations, you learn a lot. Maybe you can talk a little bit what you learned.
Yeah, so we learned a lot, definitely. One of the main challenges is, of course, growing a company really fast. So we started with 30 people 3 years ago, and now we are 250, building a new factory, starting automizing processes, and the growth factor, it's really a challenge. Also entering a public market for financing, so that's really from a non-technological point of view definitely a challenge. From a technological point of view, of course, scaling is also difficult, and it requires a lot of investment, a lot of political support. So we are really happy to be in a positive atmosphere where the environment, where the government is also incentivizing such innovation. However, we do feel like more push is needed, especially from the European Union as a whole and not just from single governments. So definitely policy support, scaling both the technology and company are the two biggest challenge. And of course, from a market perspective, what we've seen so far is the high cost of electricity. That's also what it's making a lot of business models for hydrogen right now not taking off, let's say, because if you start with high cost of power, then the hydrogen is expensive, and then the e-fuel or the e-methane which you're trying to produce gets expensive as well. So a strong public support for widespread low-cost renewables is needed, and this is also, I think, a bottleneck of the industry overall. And from a more, let's say, electrolysis technology point of view, and then I shut up, I promise. It's just a matter of researching and investing time and making your technology stand out. So we've invested a lot of time and worked with a lot of universities and have a really strong focus on R&D just to fine-tune our technology. But yeah, it needs a lot of place in the market to show the industry which we really can produce hydrogen at lower cost. So yeah, that would be my comment.
So Ruben, thank you for sharing these insights. Will somebody from the podium comment? Yes, please.
Okay, and thank you very much. And I think the overview of industrial heat and also mobility, and I think there is, from the systematic viewpoint, there are several candidates for decarbonization, and which has application area is separated and also a little doubled. Therefore, we should focus several technology innovations simultaneously. That is I want to point out.
Yakabe-san?
Yes. So both methane and e-fuel is a very important issue to solve the decarbonization in the hard-to-debate area. And it takes so long time to deploy and implement all these technologies and businesses. Therefore, we hope that so the government support all over the world and partnership with many stakeholders is important. And we will focus on this issue for a long time. Thank you.
So I will thank all the speakers for these excellent presentations, and in particular, Ruben, you gave us a good idea how the youth will solve our future problems. Thank you.
Thank you.